So, hello everyone. My name is Riya Kansagara, and let's discuss a topic that is data warehousing. Here we'll discuss the concept, architecture, and the methodology behind data warehousing. So, firstly, what is data warehousing? So, data warehousing is simply we combine multiple sources of data where in a staging site we just combine them and transfer in the centralized data warehouse, which is simply like a, if we have multiple sources, we simply have a ETL process where we combine this data, that is extraction from different operational sources, transform them and load in the data warehouse, which is simply we store data in a cuboid form where we have raw data, summary data, and metadata. So raw data is the complete whole data which are abstracted from the operational sources, which are generally in unstructured data and flat files. Then in staging process, we extract all the data from the data sources. We transform that. In transform, we do data aggregation. We try to avoid data duplicacy. Then we load them in the data warehouse, which is the centralized comprehensive data with multiple sources. Okay. So historically, before 1980s, the data were simply in the operational objectional data sources. Then the data warehouse come with the evolved from basics like relational database, non-relational database, and the cloud computing. And the main operational database where simply it stored the transactions data, whereas data warehouse stores historical data, which helps in analyzing the data and find future trends for reporting, for business intelligence, and for data mining and data analysis purpose. So these are the core fundamentals of the data warehousing. Firstly, it's the subject or oriented. Let's suppose let's suppose if we are creating data warehouse for the business purpose, so there we will have multiple sources from different trading sites or some things where we integrate and we try to find the future prediction, like in which stocks or shares we should invest which have possible profitable. So it's mainly the business subject oriented. For the financial subject, the data warehouse have a details about the sales, stocks, trades. If we are talking about the retail, so it may combine the fabric we are using on the seasonal basis. So future trends will be like for the summer season, more cotton fabric should be used, or cotton textile market should be more focused before summer. So while during the summer, the all malls and are consisting of the cotton fabrics or light fabrics, so such like that integrated. As we have seen that the data warehouse integrate from multiple operational sources. The mainly the operational sources consist of structured data, semi-structured data, and the flat files. The time variant of, so data warehouses stores data, historical data, like from beyond the years of data for finding the future trends or market trends, so the business make more profit by analyzing this. And then it's non-volatile. So once the data entered in the warehouse, so it is not updated frequently, just like a operational database where the transactions are updated eventually. Okay. So building blocks, so data warehouse and data warehouse. So simply, this is our data warehouse where marts will be the small subsets of our data warehouse. So for example, if this is the data of complete enterprise, then this will be different from departmental wise. If we take example of the DMart, so warehouse of DMart have multi from textiles to like for daily household groceries and all. Then if we consider the subset, then we distribute in this different section where all grocery items will be in the separate, the textile like garments and fabric in the separate area. So household codes like kitchenries, utensils, this all in the another, the home decor will be another section. So these are the simply the subsets of the main data DMart warehouse, which was combining of all type of data. So here, that's only the data warehouse integrates data across the entire organization, serving as the central repository that supports enterprise-wide analysis and reporting needs. So which I was saying that if the godown of the DMart is just a data warehouse or DMart warehouse where from for home decor the section or will be separate, we can consider as a subset, so which is our data mart. So such like that. Interrelationally, like data marts are the centralized data where her data mart consists all the data of the data warehouse only, but it's distributed with a certain criteria, or we can say departments. The key features of data warehousing are scalability, consolidated reporting, advanced analytics supports, historical data storage. Firstly, scalability. As data warehouse is designed in such a way that it can combine huge number of data simultaneously. So that's why it can scale or grow seamlessly, but ekdam feasibly, okay? Because the data are coming continuously in tons, in TBs, PBs, so it auto scale or expands accordingly seamlessly. Reporting, as data warehouse is a centralized data, so a business owner can get comprehensive data about its business core from the business core data, and he can or she can find the perfect insights from his or her databases. Advanced analytics supports. So it has support sophisticated analytical technique, like it can use for predictive analytics, enabling organization to drive deeper insights and forecast trends. So let's take example of regular DMart or shopping mart, where we can see that if there are breads, buns and also jam, butter are kept near that. If pulses are there, we are getting some pre-mixes, then spices, then some pre-mixes spices in a arranged in the way. So they have derived that patterns from the historical data, that if someone is purchasing bread or bun, it's high possibility that he will or she will go for butter, jam or some dairy milk, for if he or she is taking bread with a tea or coffee, or breads obviously if he try to cook. So these are the trends they obtain from the historical data. If you have noticed in the market near the counters section, there are many kids products like chocolates, toffees, small few kids attractive things, because during the billing counter a child will, and it's kept near below area, so child can easily take it. Once it take it, he or she gonna request parents to buy it. It's kind of emotional shopping which child is doing, and for the business purpose is my benefit. Now my products is selling or my chocolates are being sold more. So for this, trend analysis is compulsory. Historical data storage, as it's a comprehensive central data, so it has the past data, historical data in bulk, so which helps in benchmarking and supporting studies and analysis. So what are the common issues and challenges? First, data quality and consistency, ETL complexity, performance bottlenecks, security and governance. Firstly, if we discuss about the data quality and consistency, in data warehouse from multiple operational sources, data is passed through the staging site, which where ETL process is done, where extraction from all the operational sources, then it transforms. It will do basic data integration, data sorting, or data arranging. So while doing aggregation and this may possible, we lost some crucial data or data quality may affect. So this is the main challenge we face. Then ETL complexity. See, if the data is coming from multiple operational sources, so some data may be semi-structured, some will be structured, some are flat files. If we combining heterogeneous data, so there is chances that we find some little bit of complexity in transforming them. Okay, then performance bottlenecks. Obviously, as the size or volume of the data warehouse grow, performance may affect, speed gets slower, process complexity may increase, may possible the accuracy or the quality of the data start decreasing. Security and governance, as data warehouse contain crucial sensitive data for the user. If the security breaches or somewhere security concern, then the user's personal data are at high risk, which is very sensitive data like their credentials, their account details, their health details, which can be used for any unethical term also. Benefits and business value. So it improved decision making, faster reporting cycles, cost reduction over the time, competitive advantages. As data warehouse is advanced level feature, so it access to consolidate accurate data, which empowers decision making on the timely basis. It helps with the help of visualization, we can understand the possible trends from the data, which will help in future prediction, for trend analysis, for data mining. So this is the main benefit of this. With faster reporting cycles, as streamlined data process reduce the time required to generate reports. So simply if the time decrease for the generating reports, it will become faster and more feasible. Cost reduction, if is over the time, if we start using the process more optimistically, so we will start saving cost in the complete process. Competitive advantage, the harnessing the power of data analytics position business to innovate and stay ahead of their competitor. Simply if there are multiple markets. For fashion brands, there are multiple brands. For if we talk about butter, there are multiple trends. So over the time, by trends, market trends and analysis, they can come with new offers or new invention of flavors or new quirky style in the fabric or garments, we can say, introducing more synthetic fabrics which are quite cooler for them, so which will eventually help in growing their business and get ahead from the rival brands and companies. So architectural overview, so there will be multiple operational sources which comes in a staging area where we do ETL, then data warehouse, which data we can use for reporting, business intelligence, data mining, predicting future trends. So simply source systems. So we get data from different operational databases, flat files which are heterogeneous in nature, because obviously the data are coming from different sources. So it's quite complex and it's in heterogeneous. Then we map all that data in a data warehouse by using extraction, transformation, and load. Then the data warehouses, if then it's converted into its subsets which are called data marts. Then it's go for future trends prediction, data mining, business intelligence, and reporting. So source systems, which are our operational sources. Then staging area, where we do ETL process, where we gather the data, we extract, transform, and load them. Then our data warehouse, which is the storage, and then the presentation area, which is used for reporting, BI, and the analytics purpose. So now metadata in the data warehouses. Firstly, we discuss what are metadata. Metadata is simply data about a data or data of an data. Let's suppose in gallery we have stored so many images. Images are the data. If you search for the details or settings part, we see dimension of the image, size of the image, pixels, the time when the image is being created, the source or file where the image is being stored. So these are what? Data of the image. Image is a data, so it's data of a data. So it mainly facilitates the data discovery. Like if in the time of data mining, data warehousing, or any operation in the data, the metadata helps to get some instance or some insights about the data or databases, that what kind of data is being stored, what type, when the data is stored, the size of the data, or at which stage it's being stored. So it simply helps in analysis more efficiently. Instead of accessing complete the data from the metadata, we get to know which type of data, or which help in tracking the changes and all. And metadata drives automation in ETL, providing the necessary information to streamline data extraction, transformation, or loading stuff. Which already I said that metadata simply give the insights of the data, which is very help and will automate the ETL process, as we don't have to access or go inside the complete data for managing the tasks. We simply automated layer by getting insights from the metadata. Categories of metadata. So there are four main categories: technical, business, operational, and governance. In technical metadata, the metadata contains some technical terms like data types of the data, size of the data, the source, like it's from MySQL or it's a MongoDB data. So this kind of the metadata which are purely into technical terms, which gives more detail to a developer while engineers to while operating the data. Second is the business metadata. When it comes into the businessman or business owner, they don't understand the technical terms, so they need metadata in a non-technical terms. Like it may contain, the metadata should contain like this data is about the stocks, or the stocks till FY 23-24. So this type of metadata which related to business terms and a non-technical person can easily understand, then it's a business metadata. Operational metadata. In this metadata, it contains time span, that the status of ETL process. Like for example, if it passes through the extraction of the extraction database, so metadata will come to that successfully extraction done this during this time stamp, or such that when it's, or if transformation fails, so in metadata it will be mentioned the transformation failure, so which is helpful for the uh, team stack to understand where the process is stuck, which part or operation has done completely and all. Okay. Then governance metadata, which simply supports security access rules, ensuring data governance, which it for this metadata it contains security level terms and all, which is helpful for protecting the data. So data warehouse models. So firstly we discuss about there are two approaches for data warehousing. First is top down, which is inbound, and bottom up. In top down we create data warehouse first, then we convert it into data marts, and in bottom up approach we firstly create data marts, then combine it into and centralized into a main data warehouse. So simply the two approaches are, firstly from ETL we transform into a main data warehouse which complete raw data, then we create subsets from the data warehouse, while in bottom up approach, that is Kimball approach, we firstly convert, extract and load into data marts, then we combine and centralize it into data warehouse. Okay, so these are the approaches for the data warehouse. Now we come upon the data model. So firstly there is star schema. In star schema we have a fact table which is connected with dimension table. So this is a star schema. So for star schema we have a fact table which is connected with many dimension tables. So what is first of all fact table and dimension table? Fact table contains only numerical values and the primary keys of all the data. Dimension table which is connected to the fact table, and dimension tables are the descriptive table. Let's suppose for an example, this the fact table is order table. Here we have products, cart, customer, and seller. So this fact table will consist all the primary keys of this table, plus it can have number of item, total amount, so simply you get the idea. Dimension is the descriptive table of products like product ID, product name, product price, product color and all. For cart it will be like number of items in the cart na, so for each product which is added to the card of specific user or customer. Then customer table where it has detail of customer like customer name, phone number, email number, address. Then seller, the product is being sold by different sellers, so it also contains the detail of the seller. So this is what star schema is, and I guess you understand what is fact table and descriptive table. Now we have snowflake schema, again a fact table which have many dimension table. And this dimension table also have sub dimension tables. And accordingly this, so it's creating a star or snowflake like diagram. So that's why it is called as snowflake schema, where fact table is connected with data table, and data table have one or more sub data tables, which is dimension tables. Then normalized and denormalized layouts. So simply when the data is normalized, that is it minimizes redundancy, enhancing data integrating, while denormalization optimize performance of the cost of storage efficiency. So methodology, like obviously if we start developing a data warehouse, there are many step-by-step approaches. Firstly, requirement gathering and scope definition. The core business peer team will gather to find the actual objective and scope for creating the data warehouse, so we can get expecting output which aligns with a business goal. Then conceptual, logical, physical designs. Then we will design a multiple layer architecture for throughout the process and the flow, where each layer describes the each stage of creating a data warehouse. Then validation and deployment. After creating a complete data warehouse, we start testing and validating it, so we can get maximum accuracy and performance, better performance. Then finally we do the evaluation of the data warehouse for like performance tuning. If the changes is needed, then we will go for that. Scalability adaptation, supporting continuous data or not, and management practices. So this is the life cycle of developing a data warehouse. So thank you. So this was all about the data warehouse.